Okay, so here's a couple of examples of t-interval problems. In this first problem, we're looking at a sample of 36 homes from a metropolitan area that were built an average of 37.8 years ago with a standard deviation of 10.2. Calculate and interpret a 95% confidence interval for the mean age of all homes in that area. So first, let's notice why this is a t-interval problem and not a z. Here we're given a standard deviation, but keep in mind this standard deviation comes from the sample. Therefore, that's not sigma, that's S. So here we have a sample of 36 homes have a mean of this with a standard deviation of this. That's one of the really common ways that they say the sample standard deviation, or S. In order to do this, we need to know that either we are sampling from a normal distribution, and there's nothing in here to indicate that, or we have a large enough sample size. And here we do. So we have 36 homes in our sample, so that's fine, so we can do the t-interval. So let's first figure out what the value of t is. So in this problem, the area in two tails, because it's a 95% confidence interval, it's 1 minus 0.95, so that's 0.05. And we need the degrees of freedom, which is n minus 1, so 36 minus 1 equals 35. So let's go to our t-table. So we want the area in two tails to be 0.05, so that's this column right here, and we're going down to 35 degrees of freedom. So 35 degrees of freedom in this middle column is 2.030. So 2.030. Okay, so now plugging in here, do like I did last time. I'm going to copy and then paste down here. So x bar, we know from our sample, is 37.8. Our t value is 2.030. S was 10.2. And n was 36. So if we do that on the calculator, you can do that all in one step if you want to. 37.8 minus 2.030 times 10.2 over the square root of 36, that's just 6. We get 37. Oh, I made a typo. 37.8, not 37.28. So 37.8, 34.349 on the lower side. And then on the higher side, we get, oh, I made a mistake here. So on the higher side, all we have to do is entry and then change this to a plus. And we get 41.251. All right, and then our interpretation is, of course, we are 95% confident. The true mean age of homes in this area is between 34.349 years and 41.251 years. All right, so that's doing it by hand. Let's do the same problem using StatCrunch. So I've got StatCrunch pulled up here. Here all we have to do is go to Stat, T-Stats, one sample with summary, and then we just type in our information. Our sample mean was 37.8. Our sample standard deviation was 10.2. Our sample size was 36. And we want a confidence interval with a 95% confidence level. And we just go to compute. Copy all this, of course. Control C. And then come back over here and paste your answer. And of course with the interpretation, because I don't ever want you to do a confidence interval without an interpretation. Okay, so that's if you're given the summary statistics. There might be some problems like this one where you would be given raw data. So this is another example from an old test that I gave. So we have a sample of 12 SUVs that have the following gas mileage in miles per gallon. And here we don't know that the data follows a normal distribution. We don't see a histogram or anything, but you're told, so that's fine. So now let's go back to StatCrunch. And this time we're going to paste in our data. So I'm just going to go to this cell and do Control V to paste the data in. And now Stat, T-Stats, one sample with data. And now we move variable 1 over there. And we do a 95% confidence interval for mu. Compute. And there we have it. Control C to copy. Come over here and paste. And we are 95% confident. The population mean mileage is between 8.4563 miles per gallon and 11.2103 miles per gallon. All right, I'm not going to ask you to do these by hand. So all you have to do is do these in StatCrunch, these ones that you're given the raw data. All right.